Let us look at some exponential equations that contains radicals. In the first example, we have 3 times the square root of x minus 1 equal to 27. If I isolate the square root here, on the left hand side, I have to divide both sides with 3. So I will get square root of x minus 1 is equal to 9. Now remember that square root is the same as to the power of a half. So to get rid of the square root, I must square both sides. In the center we have x minus 1. So here we have the 2 times a half gives us 1. So on the left hand side we just have x minus 1. On the right hand side we have 81. So we can conclude that x is equal to 82. By substituting 82 back into the original equation, we can check whether it satisfies the original equation. Let us now look at the second example. In this case, we have 2 plus a radical, and whereas in number 1 it would not matter if we square directly containing the 3 or not, here it does matter, because if we square the left hand side we will not get rid of the square root, and that's the purpose of the whole exercise. So first of all we isolate the x squared minus 1 on the left hand side by subtracting 2 both sides, so we get x minus 2 on the right hand side. Now we can just square both sides. Remember that square root is the same as to the power of a half, so the square and the square root cancel each other. So on the left hand side we have x squared minus 1. On the right hand side we have a trinomial, so we get x squared minus 4x plus 4. We immediately see that we have x squared both sides, so we can subtract x squared on both sides, and then we have no term containing x squared. If we take the minus 4x on that side, if I subtract or if I add 4x on the right hand side, I must also do it on the left hand side. So I will get 4x on that side. On the right hand side, the minus 4x plus the 4x is 0. I have a 4. And this minus 1 here, the minus 1 there, if I add it both sides, plus 1, I will get this. So in the end, I will have 4x is equal to 5, or x is equal to 5 over 4. It is crucial that you always test your answers. In this case, we only have 1. Remember, we had x equal to 5 over 4. That is the result that we got. And now we're going to substitute it into our original equation. Before we did any alterations, we keep the 2 plus, and then we will put the 5 over 4 inside the square root minus 1. And if we simplify here, we get 25 over 16 minus 16 over 16. That will give us 2 plus 9 over, this is a 5. 25 over 16, that will give us 9 over 16, still inside the square root, which results in 3 over 4. We can simplify that as one number or a mixed number 2 3/4, or we can write it as 11/4, it doesn't matter. So if we look at the right hand side and we substitute that x equal to 5/4 in there, I get 5/4. And you can clearly see that this and that is not the same. So that means that the left hand side and the right hand side is not the same, so there's no solution here. No solution for this equation. You can also check this by drawing the graphs, and you will see that they will never cut each other, which is a very interesting case. Number 3 is a very simple equation, and normally this is what happens when you've done some simplification, and then this is sort of the final part of your final step of your solving your equation. I want to get rid of that minus 3/2. So if I want to do that, I must multiply with its inverse, multiplication inverse. So it means that I have x to the minus 3/2, and I must multiply it or to the power of minus 2/3. And what I do on the left, I must also do on the right hand side. And in this case, this and this becomes 1. So on my left hand side I have x. On my right hand side, I must first write 8 as 2 to the 3. And then I times to the power of minus 2/3. And remember, this is over 1, so if I simplify, I get 2 to the minus 2, which is in this case 1/4. Let us look at number 4, where we have two terms, each of them containing x to the something. In the first case, we must remember that x is to the power of 1. So if I take the largest factor that I can take out here to factorize, I can take out a 3 and I can take out the x. So then in here, in the bracket that's remaining for the first term, I must have x to the minus 2/3, because here I have x to the 1. And minus 2/3 will give me 1/3 again. Minus 1 minus 2/3 gives me 1/3 again. So now I will have minus 3 goes into 27 9 times, x goes into x 1 time, and that will give me those two factors. I can then conclude that 3x is equal to 0, or x to the minus 2/3 minus 9 is equal to 0. The first one is very easy to solve. That is just 0. So whether I divide by 3 both sides, I will still get the number 0. And if I take on the right hand side x to the minus 2/3 equal to 9, that is similar to what we had in the number 3, where we had x to the minus 3/2 equal to 8. So now I will again take to the power of minus 3/2 to get rid of the minus 2/3. So that times that will give me 1. So what I do on the left, I will also do on the right, but let us write 9 as 3 squared, because perhaps it will simplify. Minus 3/2, and then I get x on my left hand side, and on the right hand side I have 3 to the minus 3, which will result in 1/3 to the 3. Again, you must check your answer. Finally, although we say by default we take out the largest factor, we can also just factorize by taking out 3 to the x to the third, and then the remainder is here 1 minus 9x to the 2/3 equal to 0. And now you can write 3 to the x to the third equal to 0, or 1 minus 9x to the 2/3 equal to 0. It doesn't matter which route you go, you will get the same answer. And as long as you test your answer